Hey there, welcome. So, you've heard the term machine learning thrown around, right? And let's be honest, it can sound a little overwhelming. Well, if that's you, you are in the perfect spot. Today, we are going to pull back the curtain on all of it. We're not just going to give you definitions. We are going to build a simple, clear map to take you from feeling lost to feeling like you're totally on track. Okay, let's just jump right in with a really practical question. How in the world can a computer look at some data about a house and predict its price, even if it's never seen that house before? Now, this isn't magic. This is exactly the kind of problem machine learning was built to solve.
All right, Section 1, solving the prediction problem. This is really the heart of our mission today.
Okay, that definition looks kind of heavy, I know. But here's the only part you really need to remember, without explicit instructions. See, instead of a programmer writing thousands of lines of code with hard rules, we just show the computer a ton of examples. We teach it to find the patterns on its own. It's kind of like how we learn from experience.
And let's be super clear about our goal here today. We're not going to write a single line of code. Nope. The point is to build a mental map. We want you to walk away with this intuitive feel for the whole landscape of machine learning so you can see how all the big pieces fit together. So, Section 2, learning with a supervisor. And this is where our map hits its first big fork in the road. The first major question we have to ask ourselves is, do we have an answer key for our data?
So in supervised learning, our data is labeled. What does that mean? It means for every single example we give the computer, we also give it the correct answer. So for our house price problem, we'd have a data set with features like, square footage, number of bedrooms, and for each house, we'd also have its actual final sales price. That's the label. We're literally supervising the computer by showing it what the right answers are supposed to look like.
Here's a fantastic way to picture the difference. Supervised learning? That's like showing a toddler pictures and saying, look, this is a doggy, this is a kitty. You're giving them the labels. Now, unsupervised learning is totally different. That's like handing them a giant pile of animal photos and just saying, hey, can you put these into groups that look similar? The kid has to figure out the patterns and create the groups of cats and dogs all by themselves.
Now that unsupervised path is a whole other fascinating journey, but we're going to save that one for another day. For our map, we're sticking to the supervised learning road. And on this road, we've come to our very next decision. What kind of answer are we looking for? Are we trying to predict a number? Or are we trying to predict a category?
Okay, if the answer you want is a number, something on a continuous scale, then you're dealing with what's called a regression problem. Just think back to our original question, predicting the price of a house. The answer is going to be a number, right? Like $500,000 or $752,000. That is regression.
It really all boils down to the kind of output you want. Are you predicting a quantity, a number, like a price, a weight, a temperature? That's regression. Or are you trying to predict a label, a category, like is this email spam or not spam? Or is this picture a cat or a dog? That's called classification. Seriously, understanding just this one difference helps you navigate a huge chunk of the machine learning world.
Okay, so we've figured out what kind of problem we have. Now it's time to open up the old toolkit and look at a few of the actual algorithms, the specific tools a data scientist would use to get the job done.
And where do we start? Well, with an absolute classic. People often call this the mother of all machine learning algorithms, linear regression. It's the first tool you reach for in so many regression problems, and the idea behind it is just beautifully simple.
At its heart, all linear regression is trying to do is draw the best fitting straight line right through your data points. For instance, it might look at a bunch of data and figure out that, hey, for every extra square foot you add to a house, the price tends to go up by, say, $200. It finds that simple, straight-line relationship. That's it. So let's switch gears from regression over to classification. For that, a really powerful tool is called the support vector machine, or SVM for short. The best way to think about an SVM is as an expert at drawing boundaries between different groups.
But here's the really clever part. An SVM doesn't just draw any line to separate, say, pictures of cats from pictures of dogs. It finds the one line that creates the biggest possible empty space, or margin, between the two groups. And why does that matter? Well, that big wide margin makes the model way more confident and much better at classifying new things that are kind of borderline.
And finally, we've got to talk about the big one, the algorithm that's behind so many of the incredible AI breakthroughs you hear about every day, neural networks.
These things can handle mind-boggling complexity, and they do it by building on the simpler ideas we've just been talking about.
So, what's their superpower? Well, with a simpler model like linear regression, a human has to basically tell it which features are important. A neural network, it's designed to figure out those important complex features all by itself.
Think of it like a little assembly line. The raw data, like the pixels of an image, goes into the first layer, the input layer. Then it gets passed through one or more hidden layers, and this is where the magic happens. Each layer looks for patterns, combining simple ideas into more and more complex ones. Like one layer finds edges, the next finds shapes, the next finds eyes and a nose, until finally the output layer spits out the final prediction. It's a cat.
And that, right there, is the game changer. This ability to automatically design its own features without a human holding its hand is what lets a neural network do incredible things, like recognize your face in a photo or understand what you're saying to your phone. These are just tasks that are way too complex for those older algorithms.
Phew! Okay, we have covered a lot of ground. We've gone from the very basics to different kinds of learning and even peeked inside the toolkit at a few key algorithms. So now, let's put it all together and look at that finished map we've been building.
This is it. This is your roadmap. It's a simple little decision tree. You just start with your problem and ask these basic questions. Do I have the answers labeled in my data? Am I predicting a number or a category? Is my problem super complex, like image recognition? Just by answering these, you can navigate the whole machine learning landscape and get a pretty good idea of which tools are right for the job. See? It's not about memorizing 100 algorithms. It's about knowing how to ask the right questions about your problem.
So, there you have it. You're no longer overwhelmed, you're on track. You now have a mental map to make sense of the entire world of machine learning. So the only question left is, now that you have the map, what problems are you going to solve? Thanks for joining me.